Hi students, welcome to the channel. So in this today's lecture we are going to talk about a very important concept of the rotational motion, where we have been given a pulley with a moment of inertia and there are two masses connected to it, as it is given in the figure that there is a mass m1 and the m2. They are connected with a ideal string, and this string is passing over the pulley, and we need to figure out what will happen if we release it, what will be the acceleration, what will be the velocity, etc. Look, this is again a very important concept of the rotational motion. As you know, rotational motion is very important and very crucial topic for our JEE mains and the JEE advanced. And after this learning the concept, I will also give you the two JEE mains question that you can also attempt from this question, from this concept alone. Alright, and by the end of this lecture you will be able to understand how do we apply the concept of this, how do we find out the acceleration for a two object and a pulley. Similar kind of concept we have also done in the Newton's laws of motion, that is called as Atwood machine, but there the pulley was massless. Here this pulley is having a certain mass, and this rope is not sliding over the pulley, it is doing a pure rolling motion or kind of pure rotational motion, right? In that condition we need to figure out. Okay, so what we are going to do is first we'll solve this with a very fundamental concept of our Newton's laws and Newton's laws for the rotational motion, and then we will develop a short trick like we know for the Atwood machine. What is the formula for the acceleration? If you remember, that is total force divided by total mass, or if I have similar kind of situation, so then I can say m1 minus m2g divided by m1 plus m2. If you remember, that is the acceleration. Similar kind of acceleration we will also get here. And then if we know the acceleration, we can of course find out the angular acceleration. So let's dive in. So here first what I will do is, let us draw the ABD of each of the body, and from there we will write down some equations. And we know that this object is going to go with the acceleration a down because it is having a higher mass, so generally we can tell higher mass will go down, and this is a lower mass, so that's why it will accelerate. And now there is no sliding at this place. Here there is no sliding, so that's why this object is going to go with the acceleration, same acceleration a in the upward direction, and then it is going to accelerate with the angular acceleration of alpha. Now there will be some relation between the a and alpha. Let's figure out that first. So what is the relation? So here we have this pulley, and rope is not sliding over that pulley, so rope is like that. Okay, now look at the points of the rope. First let's take the rope separately. Each point of the rope is having a tangential acceleration, isn't it? Why? Because each next point, if I take this point of the rope, it's going to have the same acceleration as of this object, and we have assumed that this object is going down with the acceleration a, so that's why each point of this rope is going to go down with the acceleration a, and that's why this point is also going to go down with the acceleration a. Okay, then that's why nearby point is also going to go down with the acceleration a. Why? Because this is a inextensible ideal string. And then like this we have the point, each point is having acceleration a, there is no doubt in that, magnitude is a. Okay, now let's go to the pulley. If I take the pulley separately, this is our pulley. Okay, and on this pulley we have the points like this. These points acceleration we can find out using the concept of our kinematics for the rotational motion. So as you know, if a body is performing a pure rotational motion about the axis, then we can say that the angular tangential acceleration and the angular acceleration relation is a equals to alpha r, right? So the tangential acceleration of all the points is alpha r. Okay, And now the condition is that there is no sliding. It means that each point will not have any relative motion between them. If they are not having any relative motion, what are the points? Points on the string and point on the pulley. They are not having any relative acceleration. It means they are not having any relative sliding. It means that they should not have any relative acceleration, isn't it? Yes. So there should not be any tangential acceleration. It means alpha r should be equals to a. So a equals to alpha r. This is how we say it. Not just because a is equals to alpha r, so because of that the acceleration of this and the relation between this acceleration and this angular acceleration becomes a equals to alpha. This is the reason if we go in more depth, a is equals to alpha. This is coming because there is no sliding and there should not be any tangential relative acceleration. Okay. Now let's go to the one to the object. So if I take this object, first object, so here is m1 with us. So how do we calculate the motion? First we need to do the FBD of this object. So for this FBD there are the forces acting on this m1 is m1g, like this downward gravitational force, and then there is the tension force T acting upward and it is accelerating down with the acceleration a. So we can say that the total force equals to mass into acceleration. Total force equals to mass into acceleration according to our Newton's law. Let's say take a downward positive. So then we can say m1g minus T equals to m1a. I'm sure that this kind of calculation you must have done in the Newton's law. The same way here as well on to the m2 we are going. So we can say that for the m2, here the problem would be something a bit different, because here if I take tension Te here, the tension here will be something different. Okay, so that was not the case in our Newton's laws. So let me just make a difference. Here the tension is T1 and this is tension T1 and this is tension T2. I will come to that point why this tension is different. Just let me first write down the equation. So if I take the second object, for the second object FBD is looking like this, that there is T2 in the upward direction and then there is M2G in the downward direction, and it is accelerating with the acceleration A in the upward direction. So I can say that the total force equals to mass into acceleration. So from there again, according to our Newton's law, we can say T2 minus M2G is equals to M2A. Alright. Now let's come to this point, why this tension is different. So let's draw the FBD of our pulley. From that we will get this answer why the tension is different at both of the ends of this pulley. So this is our pulley and both of the sides we have this string connected. Now what is happening? This pulley, is it having a mass or not? Yes. Is it having an inertia or not? Yes. Is it having angular acceleration or not? Yes. So now if pulley is having an angular acceleration, there should be a torque tau equals to I alpha. So if there should be a angular acceleration, there should be a torque to apply that angular acceleration. And who is going to apply the torque on this pulley? Look at the gravitational force acting on the pulley because of its gravitation, that is at the center of mass, that is at the axis of rotation, that is not going to rotate, that is not going to apply any torque. So this T and this mg of the pulley is not going to apply any torque about this axis of rotation, and that is our fixed axis of rotation. So that's why the torque because of T and mg becomes 0. So who is going to apply? If we look at the tension, this side tension is, let's suppose, T, and this side is also T, then total, because of this torque, this tension becomes clockwise. The torque becomes clockwise because of this tension, and because of this tension, this torque becomes anti-clockwise, and both are equal. So they will become 0. It means these tensions should be different. So that's why there is a tension T1 and that's why there is a tension T2. Alright, so we have come to this point that the tension both of the sides now for this pulley will be different. That was not the case with our Newton's laws of motion when we took a at-wood machine. In that case we took a massless pulley, so that's why the tension both of the sides was equal. Okay, now we can say if you apply the Newton's laws for the rotational motion, according to that, tau net is equals to I alpha. Now I know that it is going to rotate in the clockwise direction. So let's say take the clockwise torque positive. So from there we get T1 multiplied by R is the radius minus T2 multiplied by R is equals to I alpha. Now it may be, generally it will be given, R will be given in the question and the I moment of inertia will also be given. From here I can write down that the T1 minus T2 is equals to I by R multiplied by alpha. Now these are three equations. Now as you know in the mathematics, like if we have two unknowns, so we should have at least two equations so that we can solve that problem. If we have three unknowns, then we should have three equations. If we look in this problem, how many unknowns are there? A, acceleration is unknown. If I look at these equations, so what all things I don't know? A unknown, then T1 and T2 I have assumed, so they are also unknown, and the angular acceleration alpha is also unknown, and I have three equations. One more equation I need, and right here we have derived this one equation. If you look, this is our constraint relation A equals to alpha R, or a kind of, you can say, pure rolling concept, or just the kinematics A equals to alpha. So from there I can say alpha equals to A divided by R. So we get this equation that the T1 minus T2 is equals to I by R, and alpha is A divided by R. So we do get from here is that T1 minus T2 is equals to I by R square multiplied by A. This is our third equation. Now let us add all these equations. Equation 1 plus equation 2 plus equation 3. So here we have equation 1. What is that? M1G minus T1. Then equation 2 is plus T2 minus M2G. Then the third equation is plus T1 minus T2. And this total sum, I am just writing down the this right hand side of all of these left hand side, and let's go to the right hand side. Then we have M1A, then M2A, and then we have I by R square multiplied by A. If we add all of these equations, so then T1 and the T1 is cancelled out, T2 and T2 is cancelled out. Look, in these three equations, three unknowns were there, so two unknowns gone. So how many unknowns? Just one unknown. Can we figure out that unknown? Yeah. Look, interestingly, this result will be very similar to what we have got. So M1G minus M2G, these two terms were remaining. Right? Please focus on this carefully. And here we have right here in the right hand side M1 plus M2 plus I divided by R square multiplied by A. So right here we get acceleration. What is the acceleration? A is M1 minus M2 C divided by M1 plus M2 plus I divided by R square. I get this relation. Now if I look at this relation carefully, what is happening? In this relation, if I look at the numerator, in the numerator there is total force m1 minus m2, that is the total gravitational force. And if I look at the denominator, in the denominator there is the total mass m1 plus m2 plus I by r square is rotational mass. Okay, so this is our acceleration. So if we want to memorize this, we can keep in mind like this, that the acceleration of the pulley and the mass system with the pulley having a mass is m1 minus m2 g, or the net force divided by net mass m1 plus m2 plus effective mass of a pulley will be given by I by r square. Alright, so now we have understood this, then we can figure out everything from acceleration to the velocity to the angular acceleration and the tension between this masses T1 and T2. Both of these tensions also we can figure out. Now let's go to the JEE mains question. These are two 2020 JEE mains question. So here first question, it is given that a uniformly thick wheel with moment of inertia I and the radius of r is free to rotate about its center of mass, and massless string is wrapped around its rim. Two blocks m1 and m2, m1 is greater than m2, are attached to the ends of the string. In the system is released the angular speed of the wheel when m1 descends by the distance h. So try to think about this, how you will try to solve this question. You just pause the video, try to solve it on your own, and if you don't get it, you don't get any idea, try to think, try to link about the concepts. Okay, and if you don't get, then you can just see the solution. Okay, so let's do the solution. I hope you must have tried this. So here what we can do is we can apply the energy conservation. We'll say according to the mechanical energy conservation, mechanical energy final is equals to mechanical energy initial, or otherwise I can say change in the kinetic energy is equals to negative of change in the potential energy. Okay, from there what is the change in the kinetic energy? Look, this mass is going to descend with a velocity of v after height h, and it will go with a velocity v, and it will accelerate with the angular acceleration of alpha, as we have discussed in the previous our concept of acceleration and the angular acceleration. So you have angular acceleration and acceleration. So because of acceleration there is a angular acceleration, right? And there is a relation between them, that a equals to alpha r. So here we have v equals to alpha r. Alright, so then we can say that the change in the kinetic energy, what is the change in the kinetic energy, is kinetic energy gained by this particle. Initial kinetic energy was 0. So can we say it is half, both particles are moving with a velocity of v, so m1 plus m2 v square, and then this rim is rotating with omega, so half I omega square, where I know this relation that v equals to omega r. Let me correct it, v equals to omega r. And the change in the potential energy, final potential energy, let's assume for both of the blocks is 0, right? And initial was there something, so change in the potential energy finally is 0, initially is there something. So both of the blocks are going to go, like this block is going down with a h height, and this block is going to go up. So for this block final is 0, so initial is m1gh, so negative negative, because when we write down change in the potential energy, that is p final minus p initial. So let me write it so that you can understand it better. So I can write it like this, that this is our change in the potential energy of the block 1 plus change in the potential energy of the block 2. Okay, and the negative of that. Now change in the potential energy of the block 1, because it is going down, so that's why it should be negative, potential energy should decrease, so that's why minus m1gh. And now if it is going to displace by h height down, so then the m2 will go with the height of h up, so that's why potential energy is going to increase for that, and that is plus m2gh. Now here we know that V equals to omega r, so let's also put that, because we need to get the omega. So here I will write down half m1 plus m2 v square can be written down as omega square r square plus half I omega square is equals to, if I just multiply negative inside, so then I will get m1 minus m2 gh. From here I understand omega I can find out. So omega square, if I take out common, so then here this side I will get is m1 plus m2 r square plus I, and 2 that side I can send, so 2 m1 minus m2 gh. Okay, so then omega becomes root of 2 m1 minus m2 gh divided by m1 plus m2 r square plus I. This is the omega. So here we get this first option correct. Like this, the second question also you can do. Here also we need to find out the angular speed. Same concept is there. You try it, you can get this answer. Okay. All right. So thank you for being in this lecture. You can also look at the other lectures of the rotational motion. I have also done some concept on the moment of inertia. Moment of inertia is also a very good topic of this chapter. Thank you.